So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today our topic will be for discussion, types of data in GIS. So today we'll be discussing what type of data we are going to use in GIS, how it works, what type of data, how it is entered, and how it is displayed. Different sources, types of data we'll be discussing today. In the previous lectures, in the introduction of GIS, we have discussed the definition of GIS, what are the types of features we have which we display in GIS, what are the contribution disciplines in GIS, and the history of GIS we have discussed in the previous lectures. So in today's lectures, we will be discussing about the different types of data because from remote sensing and photogrammetry, we just try to collect the information, the data is collected, but how it is used in GIS further to integrate both together and to give useful information to the users, that we are going to discuss today. So let us start with the contents. So in this lecture we have these few contents which we are going to discuss today, and before that we should know which types of data are required to be used in GIS. So that types of data we just when we move on to the next slide we'll be discussing in the details. So in this types of data we'll be discussing about the spatial data, vector data, raster data, and non-spatial data. So first of all, let us see what are the types of data we use in GIS. So GIS is basically, it is geographical information system, or we generally call as geographic information system. That means the information which is the Earth's surface information is provided by the this setup called as GIS. So it gives us the geographical information which is present on the Earth's surface. It displays in the system with a setup of hardware and software. So GIS data is generally categorized into spatial and non-spatial. So these two types of data is always, whenever we work with GIS, we always come across about these two types of data called as spatial and non-spatial. So let us understand first what are the types. I mean, what is spatial and what is non-spatial. So these are the two types of data which are studied together. So once you enter this type of data in GIS, then only the useful information will come out. So if you have a spatial data, and if you don't have the non-spatial data, then we are unable to uh, read the information. Then the information is not complete. It is incomplete basically. So whenever we are inputting the spatial data, we need the non-spatial data. So what is non-spatial data? Let us understand, and what is spatial data? Let us understand. So spatial data, basically it is about the features what we see around us. Suppose this is the map. So in the map, there will be many features. Many features in the sense, in the form of, you will be finding there will be a river, there will be a road networks, right? There will be a building here, there will be a tree here, or forest boundary, or water body. There are many features which we see, we understand the map language. After seeing the image, we are able to understand this kind of feature it is. But by seeing that feature, until unless we write any information to that, that data is incomplete. For example, once you see in the Google Map or Google Earth, there will be two types of information. One is spatial and one is non-spatial. So spatial information means it will show you the geographical features on the Earth's surface. Like it will show you the tree, it will show you the river, it will show you the road networks, it will show you the water body, it will show you the buildings, constructed area. So once you assign the information to these all geographical features, the information means the name of the feature. For example, you have a tree. If you have assigned this tree, you know, visually we can see and we can understand, because basically we know how the tree looks like. So once you assign the name here tree, so there are many trees, tree 1, tree 2. So if you assign the name like this is tree 1, tree 2, or some type of the tree if you assign. Same type if you have a buildings here, many buildings you have, so that all buildings look similarly. So once you assign the building name here, Building name like we assign it as building 1, assign it as building 2, and we assign it as building 3. Okay, building 3, or else if you name it as IARE building, if you name it as Aryabhatta building, something name if you give to this building, then it is easily identified. So and so building name is this. So this is what we call it as non-spatial data. Okay, this is what we call it as non-spatial data. And spatial data means this building, this tree, this lake or this forest area, this river. So if you assign a name to this river, river 1, river 2, some name if you assign to this river, that becomes the non-spatial. And what is spatial? What you see here. This is the shape of the river. What you see here is called as spatial. So what is spatial? Spatial means in the form of any type of feature, in the form of any type of geometry, or like river will be like this, road networks will be like this. So this is what, until unless we assign any information, this is a spatial. This all data is called as spatial. Okay. So once you name this river, river 1, that becomes non-spatial. So the information about the spatial is called as non-spatial. So what is non-spatial? The information about spatial is called non-spatial. Okay. So once you assign an information to the spatial data, that becomes non-spatial data. So these two things are studied together. So once you have a spatial data and you don't have a non-spatial data, that means there is no use of that particular data. If you have non-spatial data means if you have river 1, river 2, tree 1, tree 2, building 1, building 2, if you have this non-spatial data, and if you don't have the spatial data, then also it is not complete. It is not useful. Okay, so whenever you are going to insert the data in GIS, we have to insert spatial and non-spatial data together. So this is called as spatial and non-spatial. Now I'll be discussing in details with images and figures. Understanding the difference between these two types of data is crucial for effective spatial analysis and decision making. So I hope you understood what is spatial and non-spatial. So there are two different things. These are studied together. Spatial means what we see around. So a table can be a spatial, light can be a spatial, a camera can be a spatial data. Once you assign the name to that camera, once you assign the name to that table, or once you assign the name to the tree or any kind of object, that becomes non-spatial. This is the difference. Okay. So spatial data, also known as geospatial data, we also call it as geospatial data. When we study together, it is called as geospatial data. Refers to the information about the location, shape, and relationship among geographic features. Location, shape, and relationship among the geographic features. Now, so this type of data is used to represent the physical characteristics of the world. Spatial data can be represented in two primary forms. Here again the spatial data is split into two primary forms. One is vector and raster. This is very important chapter in GIS. If you understand this vector, raster, spatial, non-spatial, the whole GIS revolves around this words only: spatial, non-spatial, raster and vector. So these are very important terms you have to understand. So just carefully you have to understand. So we have two types of forms of spatial data. One is vector, one is raster. So what are the two forms of spatial data, vector and raster? These are two forms. So if you see this figure, we have raster GIS, we have vector GIS. So these are the example how it represents. Okay, so when you talk about, let us talk about raster. Raster data means the data which is captured, the data which is digital format, the data which is directly scanned through a camera, scanned through a scanner. So when the data becomes, after scanning, when the data becomes into a digital form, when there are a lot of pixels converted after scanning or clicking the photo, that kind of data is called as raster. Okay. Just if you just click a photo, that data is also raster, because Once you capture the photo, that photo is converted to the pixels. It is converted to the digital data. So that means the information which is shown in the pixel format is called as raster. So all the data which is captured through camera, all the data which is captured through sensors, these all types of data are raster data. Okay. So the data from remote sensing, from photogrammetry, or directly from the sensors which is or from a normal camera which is captured, so that kind of all information is called as raster. Or else, except this, if you scan a normal map, if you scan a paper, suppose you have a normal paper and you have just scanned that paper, so that paper will be converted to raster. Raster means the normal paper, once you scan it or click a photo of that paper, so that is converted to now digital form. Now once you zoom that in your phone or in your computer system or any device, you will be finding that there will be small pixels. That data is totally converted to the pixels. So this format is called as raster. This format is called as raster. Now, this raster data is what it is in the digital format or in the form of the pixel. So display of raster data always will be in the form of pixel format, because once you convert the data to normal map to a digital form, that becomes raster. Now what is vector? Now this is your raster data. Now this raster data, once you convert this entire information in the form of point, line, polygon. So you'll understand more better as we move forward. This is just for information I'm saying here. When you convert this entire information to a point format, line format, and polygon, that means now in this map, what you can see here is there is a cell, roads. We have roads here and some polygons, some vegetation, some buildings. So what we do generally, we convert this entire information to a three types of features called as point, line, and polygon. Okay, so point, line, and polygon is three types of features. The entire information, the entire geographical information is converted into either point, either line, either polygon. So these three types of features, first we have to categorize. Once you click a photo, once you click an image, we have to categorize which type of feature should be in the point, which type of feature should be in line, and which type of feature should come under polygon. So these three types of features we have to categorize first, and then we have to convert the entire map in the form of point, line, and polygon. So this building is here in the raster, it will be like a single cell. Same building, if you want to show in the vector, it will be like a point. So once you put a point like this, that becomes vector. Okay. So now in the, if you want to see the roads, so roads will be in the form of grid format. Okay. So roads will be like this, grid format. Same roads, if you want to convert it into vector, this will be in the form of line. So line will be like this, like this, like this. Anyhow. Same thing if you want to convert the polygon. Polygon means suppose this is water. So water will be in the form of cells. Okay, cells are covered. So this much portion is covered, this much portion is covered. These all portions are covered in the form of grids. Okay, so this same information, if you want to convert to vector, what we do generally, we just draw a line like this and convert it to a polygon like this. So that becomes polygon. So this is also known as area. So point, line, polygon, the whole information which is displayed in the form of point, line, and polygon is called as vector, and the whole information which is displayed in the form of a grid format is known as the raster. So grid format data which is displayed in the form of point, line, polygon called as vector. So we can just in normal terms we can say that raster is display of the real world in the form of grid formats, and vector is displaying of the real world in the form of point, line, and polygon. So this is the two difference. Spatial data. These two are the spatial data. Now to convert to raster, there are different sources from where we can capture the data to convert it into a raster format. So these are the few examples here. So once we, as I told you before, also digitizing from paper maps. This will be discussing. This is a very important topic. This will be discussing in the coming lectures. So digitizing means converting the normal analog data to a digital form is called as digitizing from the paper maps. So for that we need a software or we need a digitizing tablet and all. So that will be discussing later. And through scanning. Scanning also one process, like directly we can just scan the map and we can just convert the data to a digital format or to a pixels. And traditional surveying techniques we have paper records, field notes, photogrammetry, remote sensing as usual. These are the important terms we have already discussed in the previous lectures also. So directly we can get the digital data from these sources. So these are the different types of data you can see here. Now here more clearly you can understand, before slide I was saying you, how does a raster and the vector model looks like? How does a spatial data raster and vector? So suppose we have clicked a photo of a chair. Okay, suppose here is chair. So once you click the photo of the chair, that is converted to the grids. Okay, why? Once you zoom that image, you will find that whole image is converted into pixels. Any normal image if you click up, it will be converted into pixels. So these all pixels it will represent as a pixels. Each cell is showing the raster. So all the data which is representing the grid format is called as raster. Now same thing if I want to convert it into vector, the same information if I want to convert it into vector. So in the previous slide I told you point, line and polygon. These are three features. With the help of that we can convert the raster information to a vector information. So how we can convert? We can just use point, line and polygon. So this is a chair, right? So for chair, which type of feature we can use? We can use line. Okay. So we can use the line feature and we can just draw it over this. If you draw like this over the raster, you will get the you will get a vector image. So this entire information is converted into line. So that data is called as vector. Okay. So displaying of this chair in a line feature, displaying of the chair in the grid format is called raster. Displaying of the chair in the uh, line feature is called as vector. Now coming to the more detailed information about vector. So vector data is a type of spatial data model that represents the geographic features as point, line and polygons I told you just now. So the entire information will be represented in the form of point, line and polygon. So these features are defined by the coordinates and can be used to represent various real world phenomena such as roads, rivers, buildings, administrative boundaries, etc. So whatever information when you want to convert, we have to use it either point, either line, either polygon. So vector data is widely used in the geographic information system and other spatial analysis application. Okay, so vector data is point, line and polygon. So what are points? So points represents discrete locations such as city, well, landmark. So in a map, you will be finding a lot of information. So in a mapping sense, when you click a satellite image, if you go to the top of the building, if you have a camera in your hands, you want to just click a photo out of the boundary of the building. So after clicking the photo, you may find there will be many features in the photo. Okay, so many features in the photo. You may find a pole. Okay, you may find a pole. You may find a building. Okay, you may find trees. Many trees you can find. You can find road networks. Okay, road networks. You may find a river also. You may find a drainage also. You may find a forest also, right? So there will be many features over there. Now what we have to do? What we have to do? What we have to do is we have to just categorize which type of features can be represented as points and which type of features can be represented as lines and which type of features can be represented as polygons. So we have to categorize this first. So for example, I showed you we have a pole. So pole can be categorized as point. Okay. So you have a building here. Building can be categorized as this also can be categorized as point. Okay. And later, if there is a river, river can be categorized as polygon. Okay, polygon or line we can say. Or this tree can be categorized as point. Okay. Road networks can be categorized as line. So we have to categorize the features first, and then we have to decide which type of features comes under point and which type of feature comes under line, which type of features comes under polygon. Later we have to categorize here. So points represents the discrete locations such as city, well, landmark. So if you want to just locate a city, if you have seen a map, surveying map or a normal map also if you see. So if you want to mark city, for example, let us say Hyderabad city, how do we mark it? We just put a point and we just write as Hyderabad. Okay, like that if you want to mark a city against Hyderabad. So any locations we have to mark or cities we have to mark, we just use it points. So like that if you have well, what is well? Well or tubular well if you want to mark, we have to just mark with a point. Okay, like that if you want to mark a landmark, you just will put a plus sign or just will put a point here and we can mark it as landmark. Now these are the different features which we can see in the map, and we have to categorize as points. Now we have to categorize as lines. So how do we represent line? Line is a linear feature such as roads, rivers or pipelines. So if you want to show this all features which is already clicked in our image, if you want to show this, then we have to convert the entire information to a road, to a line feature. So what we have to do in this image, if you have, we have to draw a line feature and we have to name it. Suppose NH5 road is there, NH6 road, or state highway road is there, state highway 2, something like that. You have to do this represent it. Rivers, if you want to show, you can just show it as a lines, and pipelines, if you want to show, you can show it as a linear feature. Now polygon, so what type of features we can convert the features into a polygon? So such areas like lakes. Lake is a closed feature. So all the closed features we can show it as a polygon, or we also call it as area, polygon or area. So lake, if you want to show, we can show as a polygon. If you want to show a forest boundary, we can show as a area or polygon. Okay. Any village boundary, if you want to show like this, village boundary or state boundary, these all will be categorized as polygons or area. So represents areas such as lakes, parks, or property boundaries if you want to show. These are the vector data features. Okay, either point, either lines and polygons. So these are only three features which you can see in even Google Map also. Once you open a Google Map, we have a two view. One is satellite view, one is map view. When you go to satellite view, you will be seeing the actual image, right? That is the actual data which is clicked by the sensor. And if you want to see the map view, there you can see either that whole information is converted to line, point or polygon. So if it is location, it is marked as point. If it is line feature, linear feature, it is marked as road or line. If it is polygon feature, it is marked as polygons. Now here it's very clearly easy to understand. Now this is one example of point feature. So distributed entities, activities or events, points spatially have a single geographic coordinate such as suppose for example tree, if you want to, it has a single coordinate, tree or traffic accident point if it is there, lamp post is there. Now here this is the actual image, okay. So this actual image, if you want to represent in point, if this is the tree, if you want to show in the map, we have to show it like this. This is a point feature, we have to show in the form of point. So point has different symbols. If it is a tree, you have a symbol like a tree. If it is a temple, you have a symbol like a temple. If it is a pole, you have a symbol like a pole even. So we have different symbols in the software. This all information we convert it into software. In the coming lectures, I'll be discussing you about the software part, how it is converted, how it is digitized. So first introduction we are going to discuss here. Later part we'll be studying about the different operations, how we do and how we convert the normal information to a vector data. Okay, so this is one example. Now we have line features here. Spatially distributed entities, activities or events. Lines are series of geographic coordinates joined to form a line such as road, stream and railway. So here we have a road here. in the actual, this is the actual image. So in this actual image, if you want to represent, so this is basically we call it as raster. Okay, when it is clicked as a photo. Now this raster is converted to vector. How? So it is converted to line. Okay, so now this is this is raster, this is vector. Line feature is shown here as a this road is shown here as a line linear feature. Now area or polygon features. So spatially distributed entities, activities or events areas are series of geographic coordinates joined together to form a boundary such as lake or soil types. So if you want to show a lake, this is the real world. This is the actual image of a lake. So once you click the photo of this lake, so if you want to convert it into vector. So what we do generally, we take a polygon feature and we convert the entire information into lake. Okay, and this will be represented here as lake, and it is named as a lake. So I hope you understood about this vector data, points, line, and polygons. So once we click a photo, or if you have a satellite image, if you have a photogrammetry image, aerial photo. So these all data we have in the digital format, and then what we do is first we categorize it, like which type of feature should be in the point, which type of feature should be in the line, and which type of feature should be in the polygon, and later we just convert the raster information to the vector information. Okay, so it's like in Google Map how we see a satellite image and the map view. So the satellite image is the raster image, and the map view is the vector image. Okay, so the entire information is converted to vector. Now coming to raster data composed of grid cells, as I have discussed before also. It is composed of a grid cells or pixels where each cell has a value representing information. Each cell has a value representing information. So in the previous lectures also, once if you remember, we have discussed that after converting the information to the digital data, it will be having a DN number. Okay, we call it as digital number. Digital number. So this number will be having the information carried with each cell. So each value is representing an information such as elevation, digital elevation model, temperature, or land cover. Satellite imagery and aerial photographs are common examples of raster data. Satellite imagery and aerial photographs are common examples of raster data. So as I told you, because it is directly converted to a digital data, the satellite will give you the direct information in the form of the raster until unless we print the data that is in the raster format. Okay, so when it is in the digital format, it is in the raster format. Now coming to few more examples here. Toposheet data, this is one of the good example. Toposheet data. So this toposheet data we will be getting from Survey of India. Survey of India is the place from where we get this topo sheet. So this topo sheet will be getting in the paper format. Okay, so paper format. So if you want to work with this topo sheet data, what we have to do is we have to convert this paper format to raster data. So how it is converted to raster data? So how we can convert through scanning. Okay, through scanning we can convert to raster data. So what we do, we just bring this topo sheet data. So this topo sheet data, it will be always in A0 format, A0 size. So A0 size, we have a big scanners, which will help us to uh, convert this A0 size map to the raster. So just we put it in the scanner and we just scan with a high resolution. So this paper map will be later converted to raster, because once you scan it, the entire information is converted to the digital. Okay, each portion of this topo sheet will be having small cells. So when we zoom this data, we will be finding this data is converted to the cells. So this is the topo sheet data, and it is also known as spatial data and as well as raster data. So once we convert through scanning, that data becomes raster data. Now what type of information a topo sheet has? So this is the spatial data basically. So in this you may find lot of information like There is a river here, river. We have roads, right? We have drainage system, we have settlements here. So this raster data, if you want to convert it into vector, what we have to do? We have to use point, line, polygon. So these three things we have to use, and you have to convert this entire information to vector. This is the raster. Okay, this is the raster. Now this raster information, if you want to convert, what we have to do? We have to use point, line, and polygon. So what before that, what we have to do? We have to categorize this all features. So what are the types of features it has? It has a river. It has a forest over here. It has a river over here, river, railway network, roads, and water bodies. These all types of feature it has. So first we have to categorize this into point, line, polygon, and then later we have to start converting the information to the polygon. Okay. So here more clearly, if you see, the same image is just converted here. We have zoomed it, and after zooming you will find more clearly there is a river here, river, forest. So it has both the information. It has a spatial and it has a non-spatial. Okay. So and this type of data is called as raster. So if it is in the paper format, it is called as vector. Okay. Now this data, what type of features we have? We have a river, reserve forest. Here also you have a reserve forest. Here you have a small village. You can see small village. You have a road here, right? You have a small village here. Okay. So these all information, this raster information, once you want to convert it to vector, now what we have to do? Just take point, line, polygon. So out of this, what type of features we can convert it to point? Which type of features? Now if you see, observe very keenly, you can see here small trees are there. So these all trees we can just put a point like this, and we can write as tree. Now the small buildings, you just put a point, or if you want to show the boundary, then we can use this polygon. But if you don't want to show the boundary, you just locate it, we can just put a point and just write the name of the village. Okay. Same thing, if you want to show this river, you can just take line and you can just draw it over the raster like this, and you can mention as river. Forest boundary, if you have, just draw it like this, and you have to mention as forest. So like this. So this data is raster data, as well as it's a spatial and non-spatial data also. Raster, spatial and non-spatial data also. So this data we can just show it as a raster as well as non-spatial, spatial data, because it has both the information. It has a spatial. This is the spatial. This is the spatial. This is the spatial. This is the non-spatial. The written information is non-spatial information. Okay. Now this is the legend box. Here in the legend box you may find a lot of information which is related to the topo sheet. So in this topo sheet you see this is the symbol given. This is the symbol given for roads. This is the symbol given for different types of road. For bridge it is given. For rivers it is given. So this type of symbol, whatever symbol you can see here, this all symbol will be displayed in the topo sheet. So if suppose there is no information, there is no non-spatial information, this is the non-spatial information, this is the spatial information. So this is the spatial and this is the non-spatial. Okay. So this information is shown in the form of either point, line, polygon. Okay. So you can see here for points it has shown here lighthouse, light shape, lighted, unlighted, encourage, vine. This all it is shown as the point feature. And here if you see, this is all polygon features, linear features shown in the legend box. So this legend box is attached to the topo sheet. So when it is once it is attached to the topo sheet, it will show you the spatial and non-spatial information. So this is also once it is scanned, it is a raster, and once it is in the paper format, it is normal map. So once it is scanned, it is called as the raster image. Now, for example, more we have. So this is one area, Karamchadu area you can see here. So this is a village, it's a mandal. So in this map, this is the boundary of the mandal. Okay, boundary of the mandal. So it is shown in the form of satellite, and here you have same thing, same area. It is shown in the form of topo sheet. So if these two are, this is also raster, and this is also raster. Okay, both are the raster. Now, if you want to convert this both information to vector, so in the third map, if you see, the information is converted here into vector. Now this is vector. Why? So by taking this as a reference, the information is converted into point, line, or polygon. So if you see here, we have just converted this map into line and polygon. So these are the information given here. So this is line feature like metal road, unmetal road, car track, fat track. These are all linear features which are given in the form of line. Now here we have all this in the form of polygon. You can see here these are settlements, wet tank, dry tank, river without water, major canal, drain. So this is the polygon information. So whatever color you can see here, this color represents us. So this is only called as legend box. I was showing in the previous slide. So this is only called as legend box. Like which type of symbol we represent, which type of color we give here, what type of feature it is, either point or line or polygon. So this all shows in the legend box, and same information is displayed in the map. So later we can add this all information to the map. You can see here the information is also added, like a Magu, so a canal it is written, drainage it is written. So this map shows both spatial and non-spatial. That means it is showing the information of a spatial with a image, and it is giving the information about the spatial. That's why this data is called as spatial and non-spatial information. And this is a vector data. Why we call it as vector? Because it has the data is this raster data is converted to line feature and polygon feature. Later, if required, it is converted to point features also. Suppose we have some points over here, so we can just put the point here, and same we can include in the legend box. Like well, so if this type of feature it is point, here we can show it as well. So suppose any benchmark is there, we can write just BM and we can show it as benchmark here. Okay. So this is how the spatial and non-spatial data is studied together. When we have to display in the map. Once it is prepared, we have to display the spatial and non-spatial data. Then only the complete information will come out. And raster vector, you understood? Raster is the clicked image. Raster is the clicked image which is displayed in the form of grid format, and vector is the converted image of the raster, that is which is displayed in the form of point, line, and polygon. This is one more aerial photo we can see. So if you want to convert this aerial photo, this is the raster data as well. So if you want to convert this entire information to vector, what we do? We use point, line, and polygon. So first thing what we have to do, we have to categorize. Suppose we have a buildings. So we have categorized features like building or something like road. So I'll show you two features. So building and road I have categorized. Now what I have to do is I have to just put a point, or if you want to show it the boundary of the building, you have to use it as polygon. So suppose I want to show the boundary of this building, then I am using polygon. So if I want to show the location of the building, so I will just put the point here. So building 1 or building 2, like this. Okay, so this is how we represent. So same thing like roads. If you have a road here, so road 1, I will just draw the road 1, road 2. So I have given the information here. It's a spatial data. I have added the non-spatial data to it, because spatial data I don't have any non-spatial until unless we add the information to it. Okay, so spatial and non-spatial are studied together. So in the aerial photo also like this. Same thing in the satellite. So this is raster first of all. Always remember the image which is captured through camera or any device, it is called as raster. Once the data is converted to digital format, once the data is converted to pixels or grid cells, then it is called as raster. So the data whole information, once you convert it into point, line and polygon, is called as vector. This data also, if you want to convert, this is I can take a polygon here. I can draw this field and I can mention here field 1, field 2, field 3. Like this I can mention. Okay. So this is called as spatial and non-spatial. And raster data is raster and vector both are the spatial data. Raster and vector both are the spatial data. And once you assign the information to the spatial, it is called as non-spatial data. This is some more information, same the way we can just do with this data also. Now this is a Google Earth map. You can see here if you click a photo from Google Earth. So Google Earth will display like this. It has spatial, but it don't have non-spatial. Why? It doesn't have non-spatial because once you click the photo, it will not show you the information until unless we have to add. So what we have to do? We have to draw. Okay, we have to use the vector information. We have to draw and just add the information. Road 1, road 2, or this is a canal, right? These are the fields. Okay, this is the building. Okay, so this all information once you add, that becomes non-spatial, and this is called as spatial, right? So non-spatial data refers to any type of data that does not have direct spatial component or geographic reference, unlike spatial data which is inherently tied to geographic locations or coordinates. So non-spatial data can be numerical, textual, categorical, or other forms of information that do not rely on geographic position. So this, I think today's lecture you understood about the spatial and non-spatial. What are the two types of spatial data? We have raster and vector. In the coming lecture, we will be discussing about the non-spatial data in the detail. So we have learned here what are the two types of data, that is spatial and non-spatial. In spatial, we have two types of display of data, that is raster and vector. So what is vector? Vector is converting the raster information to point, line and polygon, and raster is the displaying the information in the grid format is called as raster. But these two data are called as spatial, and non-spatial is once we add the information to the spatial is called as non-spatial, because once we click the photo it will not show any type of information. So we have to add the information, we have to categorize the information, we have to add the information, either it is point, line and polygon, which building number, which tree number, which river number, road number, any information once you add, that comes under non-spatial information. So it can be numerical, textual, or categorical. Okay, so I hope you understood about the raster and vector. We have to discuss more about the non-spatial data. We'll be discussing in the next lecture. So these are the references which you can go through for spatial and non-spatial data. So these two data are very important in GIS and raster vector. This all GIS will revolve around raster vector, spatial and non-spatial only. So MNGRD book you can just refer for getting the more information about the spatial and non-spatial. You can just go through this link to find out the more content about it, and you can just understand about more spatial and non-spatial. Chang GIS TMH publications and corporation, you can just find out the more information about it. So these books and these links are also going to help you about getting the more content about it, and it will be very much helpful to you. So I hope you understood what is spatial and non-spatial. It is clear to you, and what is raster and vector, that is also clear to you. Raster, vector both are the spatial data. Okay, and non-spatial is all the data which gives the information about the spatial is called as non-spatial data. So in the coming lecture, we will be discussing about the non-spatial data, more information about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.